In this video, we're going to go over titrations. Titrations. Now, what's the purpose of a titration? Titrations really are used in a science lab in order for us to determine the concentration of an unknown acid or base from a known concentration of acid or base. And in order for us to do a titration, you have to have certain items, and you need to have a burette in order to have an exact volume, and an indicator to determine the pH, and we'll talk about this in a little bit more greater detail. But with acid-base titration, it's all about determining the concentration of a strong acid with a known concentration of strong base through the neutralization process. And the phenolphthalein indicator, or just the pH indicator, tells us when we've reached certain pHs, the endpoint, and we'll talk about the definition of endpoint. Now, in order for us to do titrations, this is the typical setup you'd see, where you will have the stand right here, and the stand is holding up the burette. And the burette is, the spout is inside an Erlenmeyer flask that has your little analyte, or your solution of the unknown concentration that has the indicator. And in the burette, you're going to have your titrant, and your titrant typically is the strong base that you know the concentration of. And all of that has to be on top of a stir plate, so that way you can constantly stirring the solution for a homogeneous solution. And at some point, you'll see the pH change by the indicator. Now, when you're looking at the burette, in order to determine the volume, you have to know the volume it started with and the volume end with, and in order to do that, you have to look at the burette at eye level and check out the meniscus, and that meniscus, the bottom of the meniscus, tells you the volume. Now, an indicator is what is inside your acid, or that you've added to your acid, and that is something that will tell you when you've reached your endpoint. And if you use phenolphthalein as the indicator, it should turn pink, and because you've reached neutral. Now, what is an endpoint? An endpoint is the point at which the indicator changes color. And the endpoint is something that you see in an experiment. So the key thing with this is what you see experimentally. And an equivalence point is your point at which the moles of the known and the unknown are equal, and this is indicated by your endpoint. So that's how you determine your equivalence point. It's by your experimental endpoint. In order to have a successful titration, you need to first know the exact reaction between the titrant and analyte. So you can't have a acid that you don't know what it is. You should know the acid, you just don't know the concentration. So if you have, let's say, hydrochloric acid and your base is sodium hydroxide, you know the exact reaction. The exact reaction for that would be you form sodium chloride and water. Now, another thing that you need to know is that the equivalence point must be marked accurately. So you either use a pH meter or an indicator, and the indicator will turn colors. And finally, you need to know the amount of titrant you use, so how much of the base that was in the burette was used in order to reach your equivalence point or your end point. Now, how to read the burette. you have to know that the burettes typically have markings that are to the 10th place, and your volume should always be written to the one more decimal place over, so it'll be in the 100th place. So this is something that we're reviewing now on how to do reading. One marking beyond what's, one decimal place beyond the marking is what we're going for in this part. Now, in order to read this meniscus, we would have to look at the bottom. Okay, so here's the bottom of the meniscus, and here's 21, and here's 22. So I know my number is somewhere between 21 and 22. So now, each of these other ones are going to be 0.1 markings. So this is 0.1, 0.2, and this line is 0.3, 0.4. Now, the bottom of the meniscus is somewhere between 21.2 and 21.3. So it's less than 21 point, technically you could say it's exactly on 21.3, but in my opinion, it looks like it's about 21.2, and here's where I estimate 9. So it's so close to that 21.3, I'm going to add one more number, and this number is going to be the arbitrary number. Now, there's another number you can have. You could have also written, 21.30 milliliters. Oops, forgot units. Or you can write 21.31 milliliters, just as long as they're around the same number, because that last number is our estimated value. And the first number, this number, second to last, are our last real known marking. So if we take the next one, for example, the bottom of the meniscus is right there, and each one represents 0.1 milliliter. So this right here is about 0.4 milliliters. So I would put 1.40 milliliters. Now you could have also written 1.39 or 1.41. Those are all acceptable values. Now I hope you guys remember how to do this. Let's go ahead and move on. Now, acid-base titration. So here are all the steps that you need to know. And when you're doing this, this is in a laboratory. You have to typically add your flask with acid and add 2 drops of phenolphthalein. Then you get your base. And your base, you will know the concentration. This one, you know the concentration. And you will go ahead and rinse the base with rinse the burette with your base a couple of times. So put a couple of milliliters, rinse it out, so you know that inside the burette is only the base. Now, what you're going to do is you're going to go ahead and fill the burette to the line where it says 0.00 mils, and make sure you get rid of the bubbles and record your initial volume. Okay, this is really important. You need to know your initial volume. And now that you know you've set everything up, you can go ahead and do the titration. Now you're going to add your base into your acid, and I typically would say only add it by 1 ml at a time until you see something you see that the solution in the Erlenmeyer flask goes from clear to pink. You will know when it's pink because it is pink, and typically just 1 drop makes a big difference. 1 drop will turn it pink. It goes straight from clear to pink in 1 drop. And when you have hit your 1 drop, that is your end point. This is your end point. Record your final volume once you've hit your end point, sorry. And then go ahead and find your change. So your total volume is your delta V, which is your final minus initial. And this is the reason why I say put your initial to 0.00, because it makes your math easy. Now, at the equivalence point, this tells us that the number of moles of acid is equal to the number of moles of base. Now, that kind of sounds familiar, doesn't it? Number of moles of your acid is equal to number of moles of your base. This should look familiar. It looks like your dilutions. And so the equation that we do in order to calculate the concentration of our acid is typically similar to the dilutions equation, and that is MBA is equal to MBVB. So the concentration of your acid times the volume of your acid is equal to the concentration of your base times the volume of your base. So this, if you remember in the dilutions, I showed you that this is the number of moles is equal to the number of initial equals final number of moles. So this is the reason why you could use the dilutions equation similar to it in a titration. It looks very similar, but we're dealing with acids and bases. So let's go ahead and do some calculations dealing with titration. So in this example, you are determining, you did a titration and you determined that it takes 55.05 mils of your base, 0.200 molar NaOH, which is your base, to neutralize 20 mils of your hydrochloric acid. What is the concentration of HCl? So let's go ahead and take our base, and here's our acid. Okay, let's go write our concentration for our base, and that is 0.200 molar, and our volume of our base is 55.05 mils. We don't know our concentration of our acid. This is what we're looking for, but we do know the volume we titrated, and that was 20.0 milliliters. Now, you can just go ahead and use the titration equation, which is MAVA is equal to MBVB, and we're looking for the concentration. So to isolate this, we would divide both sides by VA, and your equation for the concentration of your acid should equal to the concentration of your base times the concentration of your base, concentration of your base times the volume of your base divided by the volume of your acid. And let's go ahead and plug our numbers and get our answer. And so here are my numbers that I plugged in. Now let's go ahead and make sure we can cancel out our units. So milliliters cancels out with milliliters, and we're left with capital M, which is molarity or concentration. And our final answer should be 0.551 molar HCl. Okay, so let's go ahead and do another example. In this titration, you are trying to find the concentration of your acid again. So we're looking for Ma again. And it says there, it takes 15 mils of your base, or 0.1055 molar base, and it titrated 50 mils of your acid. So we can go ahead and write our variables. So we know Ma, Va, Mb, Vb. Again, if we put all the numbers in, this is what we're looking for. Ma, Va is 50.00 mils. Mb is 0.1055 molar. And Vb is 15.55 mils. Again, let's go ahead and use our titration equation, which is MAVA equals MBVB. And again, we're looking for Ma. So if I go ahead and use the equation, rearrange our variables, you should get MB times VB, divided by, it should be a VA. And with that said, let's go ahead and plug our numbers in. It's 0.1055 times 15.55 divided by 50.00 milliliters. And if I plug that number in, you should end up with 0.0328 molar of your acid. Now, I've given you the volumes for the last two. Here are the next couple of examples are actually dealing with information or data you would collect from a titration. So here it says there you've experimentally determined the following information in your titration. Again, we're looking for the concentration of your acid, so we need our MA. And it tells us here that our initial volume of sodium hydroxide was 0.5 and our final volume was 23.5. So the volume that we used was actually 23.50 minus 0.50. So the volume we used was 23.00 mils. That is the volume we used. So this is our V. B. Now this is our concentration of our base is 0.9990, which I can just write as our MB. And our H2SO4 is going to be 25 mils. This is our volume of our acid. Now we know all our variables from the titration. I can go ahead and just do the same thing we've done in examples 1 and 2. I've used the equation MAVA is equal to MBVB. Rearrange it so I can calculate the concentration of acid. The equation should be MBVB divided by VA. And if I plug in all my numbers, I'll get 0.990 molar times 23.00 mils divided by 25.0 milliliters. And our final answer should be 0.919 molar of H2SO4. Okay, so example 4, do on your own along with number 5, 6, and 7. And we will go over these examples in class. Thank you, bye.